Okay, so we're looking at the integral between the limits of 0 and pi over 2 of sine of 2x times cosine of x dx. Now this second term is actually quite complicated. We want to simplify this, and a way to do this is to use the substitution method. So our plan is to let y to be equal to cosine of x, and then we know that its derivative dy is equal to minus sine of x dx. Now to use the substitution, we need to find a sign in this integral somehow. And very conveniently, we have sine of 2x, but using the addition formula, we can express this as 2 times sine of x times cosine of x. So let me just write that out. This is the integral between 0 and pi over 2. This term is the same as 2 times sine of x cosine of x, and then we just leave the second term the same, cos of x dx. And now we have our sine of x to use in our substitution. So this is equal to the integral. Now we have to change the limits, but we'll do that in a second. So this is 2 times, I'll replace cosine of x by y, and then we have cos of y, because cosine of x is just y. And then our sine of x grouped with our dx, that is the same as minus dy, just using this equation. So we have a minus dy term here. And this is multiplied, obviously. So now we need to think about these limits. So just think about putting these x values into this equation to get the corresponding y values. Cosine of 0, if you remember the graph, it looks something like this. It starts up and goes down and then goes back up. So at the point 0, this is equal to 1. So cosine of 0 is 1. And we also need cosine of pi over 2. And pi over 2 is exactly where this graph intersects the x-axis. So this is pi over 2, which means cosine of pi over 2 is 0. So if we just put these in, we have 1 and 0. Now this is slightly weird because we have the bigger value on the bottom, which is a bit unusual. What we can do is we can switch the order of the limits by just putting a minus sign in the front. And very conveniently, we have a minus sign in here. We have the minus dy. So this is going to cancel another minus sign. And this is the same as the integral between 0 and 1 of 2y times cosine of y dy. So now we're left with something that we can actually integrate by parts. I'm just going to clear up some space and then we'll do that. So this is the integral that we just showed was equal to the original one, and we said that we can integrate this by parts. And the reason we can do this is we have a term in the front which we can differentiate, and our second term, cosine of y, this is something we can integrate. So if we let u to be equal to 2y and v dashed to be equal to cosine of y, and then we differentiate the first term, we get u dashed is equal to 2, and integrate the second term. So integral of cosine of y is just sine of y. And then we just need to remember the by parts formula. So this integral is equal to u times v, which is just the cross term, so 2y times sine of y, evaluated at the limits 0 and 1, and then minus the integral of the bottom row, so u dash times v, which is just 2 times sine of y dy. And we need our original limits, so 0 and 1. And this is great because we have a term we can evaluate, and this is another integral we can actually evaluate as well. The integral of sine is just minus cosine. So let's go ahead and do that. If we put a 1 into this whole expression, we have 2 times 1 times sine of 1. And sine of 1 is something you can evaluate using a calculator. You can't simplify it anymore algebraically. And then for the second term, if we put 0 into this expression, we have 2 times 0 times sine of 0. And sine of 0 is also 0. So this whole term here is equal to 0. So that's what this bracket evaluates to. And then we need to integrate this. And we said this was equal to minus 2 cosine of y. And then the double minuses cancel to give us a plus. So I'll just rub this out. And then we just evaluate this at the limits 0 and 1. So we're almost there. This whole bracket is equal to 2 times sine of 1. And then this evaluates as 2 cosine of 1 minus 2 cosine of 0. And remember, cosine of 0, that's just equal to 1. So this is 2. And we can do a little bit more simplification. This whole thing, our answer is going to be 2 times sine of 1 plus cosine of 1 minus 1. So this is the solution to our integral.